Welcome back to my favorite people. It's always good to see you, and thank you very much for watching these videos. In this chapter, we're going to go through alkyl halides, and we'll try to educate ourselves about nucleophilic substitution and also elimination reactions. But the first thing that we need to know, what's the meaning of alkyl halide? Alkyl halides are compounds that they have carbon attached to a halide or halide attached to carbon. And the halide, it can be fluorine, chlorine, bromine, or iodine. And so first thing that we need to do, let's learn how to name this compound. And in this case, the main change, it will be that one. So that's going to be the parent chain. It has 5 carbons. It will be pentane. I have two substituents attached to it. One is bromine, and the second is methyl. So I'm going to say on the second, okay, on the second one here, I have a bromo, and also I have methyl. Priority will go with bromo, so I'm going to say 2 bromo. Next, I have methyl on the same carbon, so I say 2 methyl, and I have 5 carbons, so this one it will be pentane. Now, if you have a stereocenter, you have to mention it where that stereocenter is, and also what's the configuration for it. And again, in this case, we have 7 carbons for the main chain or the parent chain, and we have 3 methyl groups. They are in different positions, and bromo as well. And as I said before, bromo will get a priority over methyl. So you start with this. We have 5 bromo. Okay. And next, on the second and third, I have methyl groups. So I'm going to say on the second, 1 methyl group. Next, comma. On the third, another methyl group. I have another methyl group. So I put the third locator number again. And so 2, 3, 3. I have 3 methyl groups. So I'm going to say tri. And then I say methyl. The compound, it has 7 carbons. So we say heptane, because it's saturated. So this one is end with ANE. Now, when I have a stereocenter, and this is my stereocenter, the bromine is facing to us. That means hydrogen, it will be back of the molecule. And that's going to be the 4th priority. So this one will be number 1. Hydrogen, it will be the 4th priority. And this group, it will be the 2nd priority. And ethyl, it will be the 3rd priority. So if I look to it, this is going to be R, okay, clockwise rotation. So I'm going to say I have R for the stereocenter. And where is the stereocenter? Is on carbon number 5. Okay, because I have only one, no need to say where exactly the stereocenter is. Assumption is you as a chemist person or somebody that's studying, organic chemistry, he or she knows how to locate the stereocenter. But if you have 2 or more, you have to show their position. Okay. Now, it depends how many carbons are attached to the carbon that is holding the halide. Reaction might decide to go with a different mechanism, or the output is going to be different. So we need to know that technically the steric, how many bulky groups are attached to the carbon that is holding the halide. Okay, so we're talking about the steric effect. Okay, and the carbon that is holding halide, and we call it the alpha carbon, and that alpha carbon, so I'm going to show it by here, alpha carbon. Okay, that alpha carbon, and if it's attached to only 1 carbon, we say this is going to be a primary, and if it's attached to groups, 2 carbons, it will be secondary, and if it's attached to 3 of them, it will be tertiary. Okay, I just said the carbon that's holding the halide. Okay, this is our halide. Okay, the carbon that is holding the halide, we call it alpha. So I'm gonna call this carbon. Okay, forgive me. I'm gonna call this carbon an alpha carbon. Okay, so that's gonna be the alpha. And after alpha, beta it will come. But then here, if you look, And on the right side, we have carbon. Left side, also we have carbon. So I have two betas. So I'm going to say this one is beta. That one also is beta. And I can say alpha, beta, gamma, and then keep continuing. And but the main stuff that I will be looking for them alpha and beta carbons. So I want to know where the alpha is and or the beta as well. And again, this one it can be gamma. Okay, so we have alpha, beta, gamma, and our betas are not identical. So how about this? Let's call this one 1 and call that one 2. And it depends which one actually you go after it, whether you go after beta 2 or beta 1, the product will be different. Okay, so we need really to label them differently. Now, the alkyl halide might go under substitution reaction, and in this case, we have a nucleophile, and the nucleophile will attack the substrate. Okay, so this is going to be our substrate, and the nucleophile is a compound that has a lone pair or negative charge. A lone pair or negative charge. Be careful. So that means you can have, for example, you can have, let's say, OH. It has 3 lone pairs, and also it has -1 as a charge, or your nucleophile might be this. Okay, it's a neutral compound like H2O, but where it has 2 lone pairs, and it can use those 2 lone pairs to kick out the halide. And in this case, the product will be such a compound. So let's say we used nucleophile, and this is going to be our nucleophile. So the nucleophile will be attached to the alpha carbon. This is the alpha carbon beta, and this one it will be the, let's say, the gamma. So this is alpha, beta, and then gamma. And what else? You got you got an X, and what's the X? X is going to have a -1 charge, Y -1 charge, because X is going to take those two electrons, and it will take them while is living, and the nucleophile will replace those 2 missing technically electrons. So you got an X that has technically 4 lone pair, and the charge for it will be -1, and this is going to be your leaving group. Leaving group from now, I'm going to show it by L dot G or LG. Okay, so leaving group, it will be the LG. That's one reaction. In this reaction, we are going through substitution reaction, nucleophilic substitution. Okay, nucleophilic substitution. So I'm gonna say this is a nucleophilic substitution. Okay, it's a substitution and it's a nucleophilic, and it depends how many. It depends how many actually and particles are involved inside the transition state. Listen carefully. It depends how many particles are involved inside the transition state. Which transition? Rate determining transition state. The rate determining. Okay, the rate determining. And this reaction, it can be SN1 or SN2. Okay, SN1 or SN2. And usually, okay, if you want to be more precise, S we write it capital N lower here, sorry, N we'll write it a bit lower, and then we put subscript here 2, or we say SN1. Okay, SN2 or SN1, it doesn't matter whether SN1 or SN2, you write first. Okay, so it's a substitution. S stands for substitution, N for nucleophilic, and 2 is showing you the molecularity, number of particles that involve. And for the first one, it says 2 particles are involved, and for the second, 1 particle are involved. So, and that means for the second one, the rate of the reaction is subject to concentration of 2 starting compound, while SN1 rate of reaction is subject only to 1 particle. Okay, the elimination reaction. Okay, you're gonna take something from the system. You will take hydrogen, okay, hydrogen from the system, and X will leave. Okay, and why hydrogen? Okay, you're talking about, a nucleophilic. nucleophile. Nucleophile, it has a lone pair, and I said it can be negative charge or a lone pair. Okay, negative charge or lone pair. And remember that halide is electronegative element, and halides are electronegative. What does it mean? It means halide will pull electron from carbon, so they will generate some partial positive charge on carbon. And carbon is going to be looking for, replacement of those actual charges. And what's the shortest wall? The shortest wall, we can take hydrogen. So in this case, base, or the base is going to go after hydrogen, and it will take the hydrogen. While it's taking hydrogen, okay, hydrogen, it will give up those 2 electrons, and those 2 electrons will be taken by the halide or X. So the product, we're going to get this one. We're going to get such a compound. We will have a double bond. Okay, this is the alkene. And what else? We removed X from the system, so this one will be -1. That means we will have negative charge on X, and also we will get H that attached to the base. And if you attach H to the base, H, it comes with a positive charge. You pair it with the base, and it will be neutral. Okay, and this reaction, it will be elimination. Okay, in the elimination, we show it by E. It depends, again, how many particles are involved inside the transition state. It can be E1 or E2. E1, the molecularity or number of particles that involve inside the transition state, it will be 1. E2, you will have 2 of them. And so that means for E2, the rate of the reaction is subject to concentration of 2 components. 2 components. Okay. Now, what's the common thing between base and a nucleophile? Okay, base and nucleophile is a lone pair. Okay, both of them, they have lone pair. Okay, and nucleophile must have a lone pair to share it with carbon that has a partial positive charge. A base, it has a lone pair that it can share it technically with hydrogen and take hydrogen from the system. Okay, so our nucleophile or our nucleophile or our base has a lone pair. Okay, now, how do I know which one is going to be the nucleophile or, like, say, the base? Okay, if you see a metal, attached to a non-metal part, highlight the non-metal part. Your non-metal part will be the base or the nucleophile. Why? Because the metal always will lose electron and will give electron technically to the non-metal. So always highlight the metal, non-metal part. It will be the nucleophile or the base technically. And if this one goes after a substitution reaction, the product will be this. You will kick the halide out of the system, and you will replace it with a nucleophile. Okay, so the nucleophile replaced technically the bromide, and the bromide now is out. And I'm going to show 4 lone pairs on the bromide to say that it has -1 charge. Why? Because the bromide took the electrons, and they took those 2 electrons that they were shared with carbon. And another one is going to be the beta elimination. Okay, beta elimination, we have 2 beta carbons. This one is beta, and that's the second beta. These 2 are identical, so it doesn't matter really which one, we attack. The base is going to attack one of this hydrogen, let's say this hydrogen. If we attack that hydrogen, and we will get such a compound. So we will have a double bond, okay, double bond there, and bromide now, it will go out of the system. Bromide, again, it will have -1 charge, and your base taken hydrogen from the system. So your base is going to turn to this. Okay, I'm going to add hydrogen to it, and so I'm going to say this oxygen will get hydrogen attached to it. Okay, so now it will be neutral. And again, because our base was our nucleophile was given, so let me just write it here. Okay, instead of saying nucleophile, so I'm going to say oxygen will attach there. Oxygen will attach there, and here we will have CH2, then CH3. Okay, and that's going to be one of our product. So for nucleophilic substitution, I got product plus the leaving group for elimination. Okay, for elimination, as you see, I got alkene, bromide, and also I got this new compound. I got this one. So I got 3 particles. Okay, listen carefully. I got 3 particles. Okay, first one, I started with 2 particles. I got 2 particles during substitution. Now here for elimination, started with 2, but I got 3 particles, and we need to include this one in our calculation.